Volcanoes. Across much of the last 5 years, there have almost always been in the range of 40 to 50 actively erupting volcanoes across the 7 continents, with usually at least a single actively erupting volcano on each continent. Yet, Earth is not the only object in the solar system to contain volcanoes which have been recently observed as erupting, or at least realistically capable of erupting again, and I mean in terms of Earth-like volcanism. By this, I mean not cryovolcanoes that eject primarily ammonia or water, but rather molten orange, red, or black-colored lavas at temperatures of 500 to 1300 degrees Celsius. So, what worlds still have Earth-like volcanism, meaning they are definitely not geologically dead? Mars, Venus, Earth, and Io. And I listed these entries in terms of how volcanically active they are from lowest to highest. But first, something to keep in mind when thinking of Earth-like volcanism on other worlds. Both the level of gravity and atmospheric pressure play a huge role on how a volcano erupts. Let's first discuss gravity. Low gravity makes typical volcanic eruptions far more explosive, yet more difficult to occur than on Earth-like counterparts. Specifically because a far larger volume of magma is needed to rise to the surface successfully on a lower gravity world, meaning that typical lower gravity eruptions are more voluminous than those on higher gravity worlds. Lower gravity also means slower moving lava flows and pyroclastic flows, taller eruption plumes, and the ability for volcanoes to form that are far larger than on Earth. On the other hand, higher gravity makes typical volcanic eruptions far less explosive, generates faster lava flows, while at the same time generates both less and more volcanic eruptions. What I mean by this is that due to a number of factors, larger rocky worlds which generally have higher surface gravities tend to have more volcanoes and volcanic eruptions and are in theory even more likely to have plate tectonics present. However, less volcanic eruptions would also occur as rising magma would have to overcome so much more pressure to successfully rise to the surface. Now, atmospheric pressure. Atmospheric pressure affects the behavior of a volcanic eruption when it does occur and the shape of deposits it leaves behind. For example, to partially understand the behavior of volcanic eruptions on Venus, you can look at volcanism on Earth that occurs at the same absurdly high level of atmospheric pressure on Venus's surface. Specifically, by going to depths of 985 meters or 3,232 feet underwater. With that out of the way, let's start on the least volcanically active world which still has a realistic potential to have another eruption, Mars. The last volcanic eruption on Mars occurred approximately 50,000 years ago and was potentially triggered by a nearby asteroid impact in a manner similar to a large magnitude earthquake storing magma about to soon erupt anyways, creating a violent pyroclastic fissure eruption. Mars does not have plate tectonics, so hotspots that form cause volcanoes that grow from them to become larger and larger in the same place, such as seen at Olympus Mons. Olympus Mons is by far the tallest and largest volcano in the whole solar system, has been intermittently erupting for the last 3.5 billion years, and last erupted a mere 2 million years ago. All recent eruptions on Mars have been fissure or shield volcano related involving basalt composition magma, and are sanely confined to these two labeled regions. Next, Venus. While having a similar surface gravity to that of Earth, the surface atmospheric pressure and temperatures are extreme. In fact, since carbonatite lavas, if they exist on Venus, have a similar albeit slightly higher melting temperature than its surface temperature, they could almost remain molten and continue flowing indefinitely. With this being said, Venus's volcanoes form primarily into subtypes: shield volcanoes and incredibly viscous low prominence domes known as pancake and scalloped domes. It is difficult to know how many volcanoes have recently erupted on Venus due to its thick blocking atmosphere, but we do know that one such lava flow occurred on the planet in 1995. After Earth, we have the furthest out object in the solar system to still have Earth-like volcanism, the moon known as Io. In its uneven orbit around Jupiter, this 3,643-kilometer-wide moon experiences extreme tidal heating due to the stretching it experiences in each 42.5-hour-long orbit. This causes immense amounts of magma generation to occur, leading to some of the most explosive eruptions in the entire solar system. Eruptions are vaguely akin to flood basalts on Earth in terms of erupted volume, except they eject vast quantities of lava tens to hundreds of miles into the sky. These then fall back to the ground and cross a large radius, helping to deposit sulfur that coats the moon's surface. As a result, vast shield volcanoes with massive summit calderas exist, and between 50 and 300 volcanoes on its surface are estimated to be actively erupting to some degree at any moment. It should thus be no surprise that a sulfur-coated yellow world is so volcanically active. If you want a more in-depth video on the geology and specifics regarding any one of these worlds, be sure to let me know in the comments section below. As a final note, I would like to thank this channel's patrons on Patreon and channel members on YouTube.